In this video, we will learn how to insert a new node in an existing doubly linked list. There are two cases for insertion. First is inserting before first node, and second one is inserting at any other given index, So right now in my example, there are 5 nodes. What are the positions where I can insert a new node? I can insert a new node before this node. So let us call that index as 0. So I can insert at index 0, or after this node, this is 1 and this is 2, second index, and this is third index, fourth. And if I am inserting at last after the 5th node, then this is 5th index. So total 6 positions are possible where I can insert a new node. So inserting at index 0, I am calling it as inserting before first node. So let us look at these cases. So first, let us see inserting before first node. What should be the procedure? Let us see what are the steps required for inserting a new node before first node or at index 0. First step is create a new node with the help of some temporary pointer. So I will create a new node. Then set the value here. So I am setting the value 10. Then how many links I have to modify? 1, 2 and this one. Total 3 links I should modify. So first I will make this as null, previous as null. So its next should point on first, and first previous should point on this one. So total 1, 2, 3 links I have modified. Then after modifying 3 links, this has become a first node. 10 is the first node. From 10 you can go to 6, 9, 3, so on. Or from 6, if you come back, you can come on 10. So I should bring that pointer first upon this new node. So bring the pointer first upon new node. So move first from here. So these are the steps I have to perform. Let me write down instructions for this procedure. First of all, create a new node. New node is created, then fill the data. This is filling the data, set the value here. Then make this link as null. Then make this link point on first. T is next on first. Then make first previous point on T. First previous on T. Then bring first on new node T. First on new node T. So these are the steps. Total 3 links are modified. 1, 2, 3. These are the 3 links modified. And I need one extra pointer T for creating a new node. So the number of steps involved here are 1, 2, 3, 4, 5, 6. Total 6 steps are there. So 6 is constant. So the time taken for inserting a new node is constant. Now let us look at another case, second case, inserting at any given position. I want to insert a new node at position 4, that is index 4. So if position is 4, so here I want to insert a new node. So let us see what are the steps required for doing this one. First of all, create a new node with a temporary pointer, say T, and fill the data here. Now this node should come in between 4th and 5th node or after 4th node. So what are the links I have to modify? I should make this T's next point on 5, previous point on 4. Then 4's next should point on T, 5's previous should also point on T. So total 1, 2, 3, 4. 4 links I have to modify. So for modifying these nodes, I should have a pointer over this node. Do I need on both the nodes or just one node is sufficient? I think on one node a pointer is sufficient. So let us take one pointer and bring it on 4th node. So directly I cannot bring a pointer there, so I have to bring it from first node. So take a pointer P and move it so that it comes on 4th node. So how many times it should move? 1, 2, 3. So it should move for 3 times, then it will be on 4th node. Now I have a pointer P upon 4th node. I will make modifications in links. Let us do it. First one, T's next is P's next. This node address is present here. P's next, that is T's next. This is the first one I am modifying. I'll remove this. We know its position is 4. Then T's previous is P itself, this node itself. So this is the second one I am modifying. Then third one, this node's previous. So I can reach this node now by T is next as well as P is next. I can reach here. So P is next is this node. Its previous, this one, should point on T. So this is the third modification. Then last, P is next should point on this node. So this is fourth modification. So I have changed 4 links. So that's how this is inserted. So from node with 7, if I say next, I'll be going on 10, then next means 2. Then again from 2, if I come previous, it's 10, then previous means it is 7. So I'm able to move in either direction, and that node is inserted in between 4th and 5th node. Now let me write down the instructions for this one. So first of all, create a new node. Then fill the data in the node. Data is filled. Then I need a pointer P upon this 4th node. So as we are already familiar that I should take a pointer P from here and go on moving it for position -1 time. So I can do it using for loop. So directly I will write down the code for moving P so that it reaches 4th node. So this for loop will move P so that it reaches 4th node. Now I have to modify links. So first link, as I said, T is next should be P is next. So T should point on this node and whose address is present in P is next. So it is modified already now. So it was present here. So T is next is P is next. Then T is the previous. This should point on P. T is the previous should point on P. Then the third link I modified was this one. So this I have to handle it specially. What is special in that? See, this is T is next or P is next previous. So whether there is a next node available or not. See, if I am inserting after 5th node, then there is no next node. So if I say next, okay, it is null, but I cannot say it's previous. So this third link I can perform only if there is next node present. So here I should do it conditionally. I should check that if P is next is available. This is sufficient. If P is next, it's not null or not 0, it's not 0. Then say P is next previous as a T. P is next previous as a T. P is next, this one. This one means this node. Its previous means this one is assigned with a T. So I have modified this third one. Now fourth one, P is next is T. So P is next is T. So all these steps are over. So these are the steps for inserting a new node at a given place. Now analysis. This was for inserting before first. Time was constant. What about this? The time depends upon movement of P. If P moves up to the last node, the time is maximum. If P remains on this one only, means if you are inserting after first node, then time is constant. So this procedure's minimum time is constant, maximum time is n. So minimum time is constant and maximum time is n. Then about pointers, links. How many pointers are required? In this case, 2 pointers are required. If you are inserting before first, just 1 extra pointer is required. How many links are modified? Inserting before first, 3 links are modified. If there is first node. If the linked list is null, just 2 links are modified. And if you are inserting at any other place, 4 links are modified. If you are inserting at the last, only 3 links will be modified. This one will not be done. So minimum 3 links, maximum 4 link. I said that this third link, we have to handle it specially. So it may or may not be performed. Now I will write a single function while writing a program. So I will write a program and show you that time I will combine these two and make it as a single function. That's all about insert. Chalo.